Question 1 from the 2022 Advanced Higher Physics Examination from the SQA. During a short test run, a dragster accelerates from rest along a straight track. The test run starts at a time t equal to 0 seconds. During the test run, the velocity v of the dragster at any time t is given by the relationship v equals 6.6 t squared plus 2.2 t, where v is measured in metres per second and t is measured in seconds. Now for 3 marks, using the calculus method, we have to determine the acceleration of the dragster at a time t equal to 4.1 seconds. Well, we know from our calculus that the acceleration is really the rate of change of the velocity. It's going to be dv by dt, written in terms of calculus. And we know also that the relationship vt is given by the following: 6.6 t squared plus 2.2 t. So our job is to find the derivative of vt, the function vt, and put in a number 4.1 seconds into it. So let's find dv by dt. So dv by dt is going to equal to 6.6 t squared. If we find the derivative of that, we end up with 13.2, and it's going to be t plus 2.2 when you do the derivative of that function. So that's now got the value of the acceleration function. So the acceleration is going to be at is going to be equal to 13.2 times t plus the 2.2. And we're asked to find the acceleration at a particular time of 4.1 seconds. We plug that into our function or expression, and we get, put a bracket around this, 13.2 times 4.1, and we have to add on the 2.2. So therefore the acceleration at 4.1 seconds into the journey is going to give you a value of 56.32, and it's metres per second for acceleration, and that's going to be equal to 56 metres per second every second to 2 significant figures. And that's the first one. Question 1a continued, part 2. Determine the distance travelled by the dragster between t equal to 0 seconds and t equal to 4.1 seconds. Well, we know that the velocity at any given time, vt, that's the formula for it, is going to equal to 6.6 t squared, and it's going to be plus 2.2 t. But we also know that the velocity is the rate of change of displacement. So we know that the velocity is equal to, in calculus terms, the rate of change of the displacement, ds by dt. So if we cross multiply here, we can get a little integral set up. We can put the v upon 1 and cross multiply to get ds is going to equal to v dt. So all we have to do is integrate up from 0 to some distance s of ds. And that's going to go to the integral in terms of time from 0 to 4.1 of v dt. So we've set up our integral quite the thing. The integral from ds from 0 to s is going to give you the distance which has been travelled, so that's going to be s. And the next part we have to put in our formula. So it's going to be the integral from 0 to 4.1 of v dt, and v is 6.6 t squared plus 2.2 t, and we have to integrate that expression up and put in the limits of it. So s is going to become equal to, and we put in our square brackets for this, 6.6 t squared becomes 6.6 t cubed divided by 3, 6.6 t cubed divided by 3. And the next part is going to be 2.2 t, we add on 1 to the power, so it's 2.2 t squared, and we divide by the new power, divide by 2, and that's going to be our integral from 0 to 4.1. We can make it a little bit easier by saying the distance is going to be equal to, keep the square brackets, 6.6 divided by 3 is going to give you 2.2 t cubed, plus, and divide this part here, 2.2 divided by 2 is going to give us 1.1, and it's going to give us t squared, and it's from 0 up to 4.1. So what we have to now do is put in our limits now. So we have, first of all, our first part, which if you work it out, we have got 2.2 t cubed, which is going to be 4.1 all cubed, and plus on 1.1 t squared. 1.1 t squared is going to give you 4.1 all squared, and we have to take away the 0 part of the limits, so obviously the t cubed is going to give you 0, and 1.1 t squared is going to give you 0, so it's going to just simply take away 0. So there's our formula to work out the distance travelled, and if you work that out in your calculator, you're going to get a value of 2.2 times 4.1 cubed plus 1.1 times 4.1 all squared, and the answer comes out to be 170, and the units we're using is metres. And that's going to be the distance travelled by the dragster from 0 to 4.1 seconds. Part B. On the axis below, sketch a graph to show the variation of velocity of the dragster with time between t equals 0 seconds and t equals 4.1 seconds. Numerical values are not required for the axis. Well, let's take a look at our formula for the velocity, Vt, and it's going to equal to 6.6 t squared, and it's going to be plus 2.2t. And you can see, looking at this by inspection, that it's going to be a quadratic equation. So it's going to be of the quadratic nature because of that t squared there. And because it's quadratic, you're going to get a parabola. And the parabola is going to be shaped like this. If I can draw up the dotted line for the 4.1 seconds, because we don't want to go any further than that. And our parabola graph will start at 0, because the function Vt when t is 0 is going to be 0. 6.6 times 0 plus 2.2 times 0 is 0. So our graph starts at 0 velocity here, and you're going to get that nice parabolic curve all the way up like that into your diagram, a smooth curve all the way up. It's very hard to do on a screen. And that is the shape of the velocity time graph for that particular motion of that dragster. Now we can actually practice drawing these graphs with a superb piece of software called Desmos, which is online, it's free. You just have to look up Desmos in Google, and it takes you to this lovely little graph paper here. And in this part here, we can put in any function we want, and we can get it graphed. You can see I've got the function already, velocity and time, because I can go over here to the graph settings, which you maybe can't see on the screen, but we'll just leave that as it stands. And you can set the axis as time and axis as velocity. Y-axis velocity, x-axis as time. All you have to do is put in your equation. Now our velocity equation, we'll call it in terms of y, was equal to, and it was 6.6 t squared. T, and we just put in squared for that. There's a squared point. And we also had to add on 2.2t, 2.2t, and that was our graph done. Now, as you can see from that, you can see you're getting the parabola type graph from 0 all the way up like that. The curve is up, the famous parabola. So Desmos is a good type of software to practice the graphs to advance higher. You can play about with the graphs and see what happens to the graph when you change maybe the 6.6 and or the 2.2. See what different types of motion give you. So as a wee hint for you, try Desmos to plot out your graphs, and you can then see what all these graphs in motion really look like.